Automation is one of the interesting and exciting topic nowadays. In this video, I want to show you how I automated 2048 Android game. I am Bhaskar. Before starting, I just want to tell you what 2048 puzzle game is. 2048 is a single player sliding block puzzle game. The game object is pretty simple. We should slide numbered tile in a grid to merge them to create a tile with number 2048. Hope this was enough for the people who don't know about 2048 puzzle game is. Let's get started. Coming to the tools and language used, I have written the code in Python. Android ADB, which is a command line tool that lets you communicate and perform various actions on your Android device. I have kept the link of ADB in the video description. OpenCV, this is an open source computer vision and machine learning software library built to provide a common interface for computer vision applications. Before going further, I just want to tell that this is not an AI, which you are expecting. Actually, this is an algorithm which calculates the best move by checking all the available moves and picking the best move. Let's jump into the code. Before jumping into the automation, I want to show you how this algorithm works. This is a basic console 2048 game written in Python. As you can see, if I run this, you can start playing the game. Like if you press up, the things will go up, R, L. You just have to specify. This is basic console game. Okay. Yeah, I just stopped this game. The code for this game is pretty simple. You can check the complete code in my GitHub repository, and obviously suggest me if I can improve this code, as I did this code just because I was feeling bored in the lockdown. So please don't expect the code to be more optimized. Okay, let's continue. Now, as you can see in this code, the user is giving the input manually. Our task is to automate the input by predicting the user input, which is nothing but the move. So let me comment this user line and uncomment these lines. Now you can see we are getting the input from some function. Actually, I got this AI algorithm from an awesome Stack Overflow discussion. I have attached the link of the discussion in the video description. This algorithm is not that optimized, as it just checks all the random possibilities and comes out with the best move. There are many other algorithms for solving this, but I just went ahead with this as it was easy to implement. I recommend you to do check the Stack Overflow discussion for other awesome algorithms. As you can see, this function again calls another function getBestMove. GetBestMove function which checks all the 4 possibilities and calculates the score and average moves for all the 4 moves. And at last it returns the best move and the best score. As I mentioned, you can check the code in my GitHub repository. As being my first video in the YouTube, I want to keep the video very short. Now let's run our modified code. You can see there are new moves coming and the score for each prediction has been calculated. And you can see, I think this code is very fast. So let's add some delay to our code. Okay, let's add delay here. Now let's run our algorithm again. After adding some delay, I think this is good. See, our algorithms comes with one of the move, that is in the first case the L, that is it says the move is left. So I think all the numbers will go to the left. In the same way, in the next run it predicts R. In the same L, D, it just keeps predicting, and we can see our game is being played with the algorithm. Okay, let's stop this. Actually, it took 5 minutes to crack and come to the state of 2048. Now let's see how we can implement that code in our Android. As you can see, I have used the ADB client library of Python to communicate and perform various operations in my mobile. The first thing I'm doing is to grab the screenshot of the Android device and extract the grid data to list. And based on that, I'll just predict by sending the list data to my algorithm. Extracting the grid data from the screenshot was the most difficult task, as this involves lots of calculations. I forgot to mention that this code only works for the phone with screen resolution of 2340 into 1080. If you want this algorithm to work in your mobile, you just have to change these values, which only crops the grid part in the image. I hope you can do some calculations. Now this cropped image will be sent to our scan image function, which extracts the grid data and returns in the form of list. Now this list will be sent to our AI algorithm to get the move, and based on the move we'll perform the actions in our Android device. Now let's check this function which extracts the grid data. This was the only function which took so much time, as this involves some calculations. Yeah, first thing I'm doing is that I'm resizing the image and I'm converting the image into the grayscale. And I'm dividing the image into 16 parts, which is the tiles, and sending each part to extract the value to this function. I'm cropping the small part of the image and I'm sending the image data to my data function, and at last it returns the value associated with the tile. Okay, let's see this in action. Let's uncomment this. I already have an image. As you can see, this is the image. So let's extract the data from this. As you can see, our function has retrieved the grid data from the image. This is exactly the same data which I'm expecting. Okay, let's see in more detail. I'm just uncommenting so that you can see how image has been cropped and the image which will be sent to this function. Okay, let me run it once again. Okay. You can see this is our first tile, that is this one, and this is our second tile. This is our third tile, which has date 2, 16, and followed by other data. Yeah, as you can see how we are cropping the image, and the cropped data will be sent to my data function. And what my data function will do is it will take the image, and I'm just copying the image so that to avoid the problems. And yeah, the other part comes here. I have already saved the data of cropped image. Like this is the data of image 2, this is 4, 8, 16, 32, 64, and so on. Before that, let me tell you one thing. The first thought which comes to brain is use neural networks to extract the values from the image, but there are still simpler approaches, so I think this was one of this. I'm using the OpenCV match template function to match our cropped image with all these images, and simply I'm just checking if the image is present. I'm just assigning the value of the file name. As you can see, the value of file name and the data present in the image is same, so I'm just converting the file name in the form of int, and at last I'm returning the value, and the returned value will be appended to this row, which is nothing but a list, and at last this list will be appended to our array, which will be returned, and which is nothing but our extracted image. I just want to take your time and tell you what this match template function is. Match template function nothing but it will take the larger image and a smaller image, and will just check if there are any matching. Let me show you another demonstration how this works. This is our complete image, and I just want to search for 2408.png in this. Okay, let me play. As you can see, this was our live.png data and 2408 image. And I think this worked very well instead of using complicated neural networks. I have kept the link of documentation of match template function in the video description. Do check that. Now, as we saw how we are retrieving the data, okay, let's go back to our Android. Before that, let me just comment these lines and save. Now, as you know that our data will be retrieved in this variable, and we are sending this variable to our AI function, which returns the best move. And based on this, we are doing all these functions. Before that, I just want to demonstrate to you how this function work. I'll just grab my CMD. I'll do ADB shell. I'll show you how this swipe down function will work. I'll just copy this data and paste this. And I think my emulator is running. As this is a swipe down function, let me click enter. As you can see, the all grids has been slide down because of this. In the same way, if you want to do it again, okay, there was nothing to do. I'll just swipe up again and again swipe down with our CMD. Yeah, this is working. So let me close this and come back. In the same manner, I'm just sending this function with our Python program. Like if the predicted value is u, I'm sending the swipe up function, swipe down function. These are the coordinates from where the swipe function will start and where it will end. The delay will be of 100 milliseconds and all those things. Yeah, I think that was enough for the code walkthrough. Now the next thing is we should see our AI playing live. Now let's run our algorithm. I have mirrored my Android screen to my laptop and let me run the algorithm. At starting, it will start number of runs. Number of runs is nothing but number of predictions it will make. Like if the value is small, the predictions will be less, and if the value is more, and obviously the predictions will be very accurate if the values are high. So to make it simple, I'll just take 100 runs and let me start. Yeah, you can see that my AI is playing the game. I am not touching my phone, just is doing automatically. This is how it works. And you can see how the score is increasing and all those things, like how the data is extracting from the image, all this. I think this was enough. Okay, let me show you how I'm extracting the screenshot. Let me show you how this works. Like CV dot image show starter image, and this is image. And after cropping, let me copy this. See, cropped image is nothing but image, and there is something called cv dot weight. Sorry, cv dot weight key, and even here cv dot weight. Now let me run this once again. Number of iterations 100. Yeah, you can see my Python code has taken the screenshot of my Android, and this is the screenshot. Okay, let me close this, and I have cropped this. I have only cropped this part of my Android phone. Let me close this. I got the prediction, and again it has taken another screenshot. Again I'm closing this. You can see the cropped grid. Again one more screenshot. Again the cropped grid, and so on. This is how it works and makes the prediction. Okay, let me close this. You just saw my code was working pretty well. That's it guys, I think this was enough. Actually I think the computation was too high, so please feel free to send a pull request to my GitHub repository for the better approaches. I have attached all the links in the video description. Thank you.